Okay, in this one I've got two shafts connected by a gear as shown, okay? And basically I apply a 500 Newton meter torque at E there. And basically what I'm trying to do is find what's going on at A and B. I want to find the reactions at A and B. So I'm going to go ahead and I'll draw two free body diagrams because I have two free body diagrams here, okay? So here is A, so again I've got 500 Newton meters applied like so. Heading in the opposite direction, I'm going to have A fixed there, as well as there's going to be a force applied at the outer edge in the opposite direction like this, and I'll call that force. And again, that's going to that interacting force between the two gears, okay, to balance that 500 Newton meters. So then if I look at the smaller gear coming up like this, that F is going to be in the opposite direction because of Newton's third law. So it'll be pushing on it on the bottom like that, okay? Which means that B is going to move, be in that direction like so. Okay, so I've got two free body diagrams, so I'm going to have two equilibrium equations. The first one basically is going to tell me, okay, well that B then has to equal the radius of 0.05 meters or 50 millimeters times that F, right? That force on the gear, that torque that's creating has to equal. That's what B has to equal, okay? On the other guy, okay, basically I've got that 500 that's applied, and that's going to be balanced out by the A as well as that F, but on the F on this one, it has 100 millimeters, so 0.1 F, like so. Okay, so there I have two equations, but I have three unknowns, A, B, and F, right? So I'm going to need another equation, and I'm going to use a compatibility equation, and basically I'm going to use that I know the interaction between those two gears based on the gear ratio, which is essentially that the 0.1 times the twist of E equals 0.05 times the twist in F. And again, this is essentially the arc length has to be same on the outer edge of those two gears, so it's just the radius times the twist on each one of those. Okay, now knowing what I know about the angle of twist, I'm going to go ahead and put those in each one. Okay, so again, it's going to be 0.1 angle of twist of E. Okay, if I think about the torque going through that, you know, if I cut it right there, I know the torque is going to be just A on this guy. Okay, so I'm going to say A times the length, which is 1.5, and at this point I'm just going to call it JG because it's going to be the same. Both shafts are the same material and are the same radius, so J and G are going to be equivalent, okay? Which means then the other side is 0.05 B times its length, which is 0.75, divided by the same JG, and again, that is because it's the same radius and the same material. So these JGs will cancel. So what I have now is I have three equations and three unknowns, okay? And going through the algebra on this, right, here's equation 1, here's equation 2, here's equation 3, okay? I can go through all of the manipulation on this, and I learned that A then equals 55.6, B equals 222, and these are going to be Newton meters because I put everything in newtons and meters on this. Okay, so again, do your statics. If you don't have enough equations, go ahead and create a compatibility equation. Compatibility equation here is using that gear ratio, knowing that R times the angle of twist, the radius times the angle of twist has to be the same. That arc length has to be same for each shaft connected by those gears.